All right, guys. We are going to go ahead and get started. Okay, for your first page here, okay, what I'd like for you to do is just pluck it off of the packet. Okay, you're going to get to use this page all the way till y'all test on this unit. So you'll see that it has all the functions we did last time, plus we're going to add 2 more today. Okay, grab your notes right there, hun, please. Okay, so the first page we're going to kind of keep separate as a reference sheet. You won't get to use the whole packet, just that top page. Okay, the first couple of these we did last time. Okay, so your linear parent graph is y equals x. Okay, and then I forgot to put a graph on it, but just sketch it. Remember that y equals x is going to be your perfect uphill diagonal. It should start at 0 and then go like that. Now, there are 2 other special types of lines, okay, Hoy and Vux. So we're going to draw those at the bottom, but they do still count as being in the linear family. So Hoy, do you remember what the H was? Horizontal. So HOY is horizontal with a 0 slope. And then it's y equals a number. Okay, and then if you want to give yourself a visual for that, horizontal should be perfectly flat across like that. Okay, then do the same thing for Vux. So for Vux, the V stands for vertical. And then the U is a special word for the slope, undefined. Undefined slope. And then your equation is going to be x equals, and then a number. Okay, if you also want to give yourself a visual, okay, remember verticals are straight up and down. Okay, so that was the first family that we talked about. We talked about 4. So number 1 is linear. Number 2 was absolute value. Do you remember the shape? What? It's a letter. It is a V. Good. Okay, put y equals. Remember, x kind of goes in like the little bars. That's your absolute value symbol. Okay, and then you're essentially going to draw still perfectly uphill to the right. But you're also going to go perfectly uphill to the left to make your V shape. Now remember, this V shape can be changed by putting numbers in the equation. But for your parent graphs, they're just the generic shape without any of those kind of adjustments. Okay? Now, last time we kind of skipped over domain and range just because we had to get through 4 families. Today we are going to cover it, but you've seen domain and range before. So domain is going to be the set of all x values that produce a real y value. And what I want you to think about for domain is you're just measuring left to right. Okay, and you're looking to see how far does the graph go to the left? How far does it reach to the right? Now, the good news for both of these functions is that they both go forever both directions. So my line goes forever to the left down. My V goes forever to the left up, but they both keep going and going. Same thing to the right. So our domain, we're going to put all real numbers. Okay, and then if you remember this symbol from last time, okay, it's a little bit shorter than having to write it. So for the other functions, I'm just going to put that little symbol instead. Okay, but for the V, it should be the same thing. Now, for range, remember for range, you're not going left and right, you're going down and up. So up here next to range, I want you to put it's all the y values. And you're gonna go down first, up second. For the line, how far down does it go? Forever. How far up does it go? Forever. So then for the range, I would put all real numbers. Okay, because I don't have any restrictions. I can go as far down on the line as I want. I can go as far up on the line as I want. However, for the V, that's not the case. I can go up forever, but I have a lowest point. How low does the V reach? What number? 0. Good. So your range would be 0 to infinity. Okay, and then I'm going to put here, this is the lowest point. And then this would be the highest. Okay, but in this case, we're listing infinity because I don't have like a true highest point that I can go to. All right, when you're ready, go ahead and turn the page. The next family that we're going to cover is quadratic. This one is also shaped like a letter. You remember what it is. Get it? U. It's the U. Okay. So go to your next one, put y equals x squared at the top. So anything with a squared in it is going to have the U shape. So start at 0. And then remember, it's a 1 jump, then a 3 jump. So it's going to be over, up 1, over, up 3. And then remember, both sides should match. So over, up 1, over, up 3. Okay, for my domain, how far does the U reach to the left? Infinity. How far does it reach to the right? Infinity. Then I'll put all real numbers. How low, though, does my U go? Only to 0. Very good. So I'll put 0 to infinity. Where 0 is where it bottoms out, but then infinity because it goes up forever on both sides. Okay, last one like that is the square root. And remember that this one's kind of like a hook shape, if you will. So you're going to still start at 0, 0. And then you're going to 1 jump to the side and then 3 jump to the side. So it's the same measurements as the U, but you're cutting off to the right. How far does the hook reach to the left? Does it go all the way back to negative infinity like the other ones did? No. How far can it go back? 0. So your domain is 0 to infinity because this is the farthest to the left that it reaches. It doesn't have an arrow on this side like all the other ones did. Okay? And then when you're measuring down to up, it's actually going to be the same thing because your low spot is 0, but then it does go up forever. So 0 to infinity will be your range. Now, you'll notice at the bottom, we're only going to add 2 new shapes, okay? But before we do that, we're just going to review some of the old shapes because they are on today's homework. It's a combo. So go ahead and take a look at your examples. Okay, first one, which family does it fall in? Remember, you have your reference sheet. So your choices are quadratic, square root, linear, or absolute value. It is linear because your x is just a regular x, right? So this is going to be linear. Remember, it's y equals mx plus b. Remember, we're going to begin with the b, then we're going to move to the next point with the m. So find negative 6. 1, 2, 3, 4, 5, 6. And then m is the slope. So hopefully you remember slope is rise over run, which in this case will be 2 over 3. So I'll go rise 2, run 3. Rise 2, run 3. Okay, take a look at the next one. Okay, our first step is going to be to identify which family it falls in. So if it's a regular x, it's linear. What about if it's an x in the bars? Which family has that on your little cheat sheet? Absolute value, very good. Okay, so I'm going to put absolute value. Okay, which we know this is a V shape. Then we talked about last time that the numbers do different jobs. Do you remember what the -1 in the bars does? Hint, it's left or right. Which one? To the right. Because remember, if it's with your x, think about like if somebody's hanging out with your x, you're never going to believe them, right? They're lying anyways. So if it's a -1, we're really going to go to the right one. Okay, then the +2 would be up 2. Okay, and we can trust the 2 because it's not hanging out with your x, right? If it's with your x, that's where it's the opposite. So we're going to go to the right one, up 2. And then normally my V opens up and it looks like this. But if I adjust the slope with that front number, it's going to change the shape of the V. So if I have a -1/2 here, rise over run is going to be -1 over 2. So I'll go down 1 over 2 and then down 1 over 2 the other way. Just like that. Okay, yeah. Did they switch it?
Yeah, I need to sign it.
Okay. All right, for both of those, think about your domain first. Okay, domain is side to side. The V and the line both go how far to the left? Infinity, how far to the right? Infinity, then we're going to put the all real numbers. And then remember for your range, you're going lowest to highest. Ethan, that packet's right there, honey, right as you walk in. The one on the left. Okay, how low do they both go? -infinity. But how high does the line go? Forever. And what about for the V? What's the highest point here? 2. So this one will be all real numbers because it's down forever, up forever. This one will be -infinity to 2. Where the lowest it goes is forever, but the highest it goes is only to 2. Okay. All right, go ahead and take a look at the next one. Okay, what family does number 3 fall in? Square root. What does the -3 with the x do to the graph? To the right, what about the +1? Up. So go to the right 3, up 1. And then remember, the reason you have this sheet is you can copy the shape. So if you look at your hook, remember it should be up over 1, up over 3. So you just kind of copy it off of your sheet. So up over 1, up over 3. All right, take a look at number 4 when you're ready. We're going to do the same thing. I notice I still have a -3 with the x. I still have a +1 at the back. So go ahead and start your hook at the same spot. To the right 3 and up 1. Okay, but there is a number that's different on this one. What number is it? The 2. Now, the 2 is going to affect a vertical stretch. And essentially what that means is that it's not going to change how far you go to the side. So the 1, 3 are going to stay the same, but it's going to stretch your hook to be taller. So write vertical stretch. Okay, and a vertical stretch is going to spread out how high you go. So instead of counting up 1 box, you're going to count up 2 boxes over 1, 2 boxes over 3. So you'll see that your original hook was a little bit shorter. Your new hook with a stretch is going to be taller because you're stretching it higher. Okay, so it's going to impact this space right here. Okay. Now, for both of these hooks, how far to the left does the hook go? You're looking at side to side for domain. 3. But they go to the right forever. And then for the range, what's the lowest point on the hook? How low is it? 1. And notice that it doesn't matter if your hook's steeper or flatter. Since they're both kind of starting in the same place, it actually doesn't really matter. Okay, so vertical stretch, you adjust the distance up. The 1, 3 jumps stay the same. Go ahead and turn the page when you're ready. Okay, next one, we're looking for which family this falls in. So it's probably not linear or absolute value because we already did those. So what family is this going to be? Quadratic, thank you. Okay, the +4, which way are we going to go? Left and then? Down 1. So left 1, 2, 3, 4, down 1. I'm going to go ahead and graph this one at the same time. It also has the +4. It also has the down 1. Okay, this one is my original U. And if you need to, look back at your sheet. Remember, quadratics are a 1 jump up and a 3 jump up. So it's going to be over, up 1, over, up 3. Over, up 1, over, up 3. But what does the next question have that the other one did not have? The number in the front. Okay, this number is going to give it a vertical stretch. Now, real quick on this, vertical stretches can only affect how big you jump up. So for my original U, I jumped up 1 and then up 3. Then those are both going to double. So instead of jumping 1 and then 3, I would double that to be jump 2, then jump 6. Okay, so you're going to go over, up 2, and then over, up 6. 1, 2, 3, 4, 5, 6. Okay, and then I'm gonna put here maybe this was a 1 and then a 3. Now it's a 2 and then a 6. So you're taking those original vertical jumps and you're just multiplying them by whatever your stretch is. Okay. All right, go down to, let's do number 7. We still have a +4 and a -1, which means that my start point is going to be the same. So if you want to go ahead and sketch, you're going to the left 4, down 1. Okay, but this time the number in the front is a fraction. So remember, your normal jumps are 1, then 3. Now we're gonna cut those in half. So instead of going up one full box, you're only gonna go up half a box. And then your next one, normally it would be 3, but if I cut it in half, that'd be 1.5 boxes, which would put you here. So my first jump was only half a box. And then I don't know if you remember from last time, but on Delta Math, if you adjust this box, it's going to fix all the other dots. So I'm not going to mark every single space, but this dot should model whatever your stretch is, if it's or compression. If it's only a half, you want it to be only half a box up instead of a full box. Okay. Also, will you write the words here? That is a vertical compression. And the reason it's considered a compression is because instead of making that one dot farther away, you're cutting it in half. You're making it a shorter jump. All right. Last one like that. We see our +4 and our -1 are the same. So we're starting in the exact same spot. But this time we have a negative and a ×3. So remember, my normal jump is 1, 3. What am I going to times those by? 3. So now it's going to be a 3, then a 9. Does that make sense? So normally your jumps are 1, 3. Now it's going to be 3, 9. And they're going to jump down. So starting right here, go over down 3. And then my 9s won't fit, so I'm just not going to put them. Okay, but remember, your standard is to be 1 away. So now I'm stretching it to be 3 away. Okay, 3 boxes away. Okay. Questions on that? All right, so let's add in your 2 new shapes. You're going to your cheat sheet. Okay, I'm going to give you the first shape, which is the cubic. Okay, so you should be looking at your little single sheet that's separated from your packet. Okay, and these actually did come up on your homework last time, but we just didn't specifically cover the shape because all the rules are the same. So put x cubed. It's going to start at 0. You're going to go up 1 on the right, down 1 on the left. And then you're going to do 1 arch up and the other arch down. And I'm just going to call this a squiggle because it really doesn't have a mathematical term to go with it. Okay, so now that you have that shape, we're going to do the example off of your packet. Okay, which is number 9. Okay, remember, all the rules are the same. What does this -2 do in the parentheses? Left, right, up, or down? To the right. What about the +1? Up. So go to the right 2, up 1. And then you're going to copy this exact shape. So you're going to do an uphill diagonal, a downhill diagonal, and then draw your squiggle. So it's going to be one side up, one side down, and then draw your squiggle. Now take a look at the one next to it. I still have a -2. I still have a +1, so my start point is going to be the same. But this time, what extra number do I have? The 3, and this is a vertical stretch. which means that instead of me only going up one box and down one box, how many am I gonna go? 3, but you don't move out further. So you should still be 3 and 3. So you're still only moving over one box because it's only affecting the stretch up and down. Okay, then this arm's up, this arm's down. And you'll notice that your squiggle gets a little bit steeper, but overall it still has the same shape. Okay. Now for both of those, the domain and range would be what? All reals. Okay, so if you want to go ahead and fill that in. Okay, for your squiggles, you got one end up, one end down, so it's going to be all real numbers for both. Okay, take a look at the next one on number 11. -2 and +1 are the same, which means I'm still starting here. But this time, what's my front number for my vertical stretch or compression? If it's a half, that means it's a vertical compression. Okay, if you're making it bigger than 1, it's a stretch. Smaller than 1, it's a compression. So instead of me going one box up and one box down, I'm only going to do a half of a box. So 1/2 up, 1/2 down. And then remember what I said for delta math, if you move one of the dots, it's going to fix the rest of the shape. Okay. Take a look at 12. What's new on 12? Just the negative, and remember the negative is going to flip it. So instead of your squiggle being uphill, you're going to do uphill to the left, downhill to the right. And it'll essentially just flip-flop. Instead of your arms being like this, they'll flip-flop and be like this, where this is the one that's up. Okay? So if it's a squiggle, it fits in the cubic family. And then we said that's all real numbers for both domain and range. All right, once you've got that, go back to your cheat sheet. We only have one more left. If you have not already, go ahead and put your domain and range for that family. Okay, remember that we said for cubic, since you have an arm up and down, it's going to be all real numbers. Okay, the last one is cubic root. So you're going to put a square root, but you're going to drop a little 3 into the elbow like this. And your cubic root graph is still a squiggle, but instead of it squiggling up, it's going to squiggle to the side. Okay, so let me show you what that looks like. Put your same 3 points, just like last time. But you're going to do your arms reaching out to the side instead of reaching up. So what I mean by that is this one's uphill, this one's downhill. So it's still doing a squiggle, but it's just kind of cutting through sideways. Okay. And that brings us to the last page of your packet. So take a look at number 13. We have a -4 inside the cubic root. Which way is that going to shift my graph? Okay, -4, we're going left or right? Okay, good, to the right. So 1, 2, 3, 4. Then I'm going to mark my uphills. And then I'm just going to trace this exact same shape. Okay, if you suck at drawing these, do it in halves. It'll make it easier. you're doing a square root hook up and then a square root hook backwards. Rather than trying to do it all together. Break it up into a hook up and a hook back. Number 14 is almost the same. I still have my -4, which is to the right. But the only difference is I have a 2 in front. And remember, 2 doesn't stretch your graph to the side, it stretches it up and down. So rather than putting my diagonals at up 1 and down 1, I'm going to put it up 2 and down 2. So up 2 on this side, down 2 on this side. And then remember, it's 1 hook up and 1 hook back. Okay, so they're both still the same shape. You're just modifying it a little bit. What will domain and range be for the hooks or the sideways squiggles? All real numbers, because you have one side of it going backwards and down, the other side's going forward and up. All right, 2 more left. Go to the right 4. This one has a stretch of 3. That means that I would take my 1, 1 box and I would just make it be 3 boxes instead. And then 3 boxes instead. Okay, so that squiggle would be like even steeper than the other ones, but still counts as within the same family. All right, then last one. Numbers on the inside are different here. Which way does my +3 go? To the left, down 1. So 1, 2, 3, down 1. Then my normal squiggle, I put all 3 dots uphill. But if there's a negative in front, that's going to flip that order where your dots should fall downhill like that. Okay, remember your negative here reflects the graph upside down. So instead of those 3 little reference points going up, now they're going to go down. And then remember, it's 1 hook forward, 1 hook backwards. Okay? All right, then we didn't mark it on your sheet, but go ahead and put domain and range for your cubic root families, all reals as well. Okay. So this little 1-sheeter, you're not going to lose. Otherwise, if you want to use it on your test, you'll have to make a whole new one. So try not to lose this. This is going to be added to your regular notes. Okay. So pull out your computers. Okay, we'll do a couple examples together just to make sure you get it, but it's pretty much what you did last time, just with a few new shapes and with some stretches and compressions. So you're going into Delta Math and you're looking for homework 2B. Which you probably can't see yet, so I'll unhide it right now. All right, you should be able to see it now. Okay, I'm going to pick one for us to do together. All right, we're going to do this question. So from the top, it's 1, 2, 3, 4, 5, 6, 7, 8, 9 from the top. So for this question, we should all have the same. So count down to the 9th question in your home. and then you can go ahead and give it a shot. Or we'll go over it here in a second. Already get into your homework. Okay, ninth question, if you want to do one together. What does the 2 in the front do to my graph? Vertical what? Stretch. So you're going to take this blue dot at 1, you're going to stretch it vertically to 2. Now, you can't also let it wander to the side. You can only pull it up or down. So make sure that your blue dot doesn't start floating off to the side. It has to be up to 2. Okay, then what does the +2 in here do? To the left too. And which dot do we grab for that? Green. Okay, so it should look like that. Okay, that is the 9th question. Okay, the very next question is going to ask you domain and range. But if it's a squiggle, automatically, what's the domain and range? All real numbers. Okay, so you can always peek back at that graph if you need to. Okay, but for cubics and cubic roots, it's all real numbers for both. Okay? So take your blue dot, shift into 2. Yeah, and then green dot. Ooh. Well, that means, yeah. Up to 2, and then green dot, you're going to shift it. Yes, correct. Okay. All right, then I feel like the rest of it's kind of self-explanatory. If y'all get to one that you're confused on, will you just tell me? I feel like you can do it though. Okay, you have like almost an hour. You have 50 minutes. Have you Chromebook? Do you want to do it on the iPhone? You can just log in though. Is your did you make the Delta Max again of it though? The Delta Max account? Were you here the first day? Second day? Then sadly, you might not able to, but yes. Okay, do you want to do the one right then? And then if you did not finish last time's homework, you can go ahead and work on that today too.